Hello, and today we're going to be talking about moon phases. This is another section of astronomy. A lot of people take a look up at the moon and they're not exactly sure what they're seeing or why they're seeing it, and I'm hoping I can explain some of that today. We'll also be talking about eclipse and solar and lunar eclipse and why they occur based on a little bit of geometry. But this is the moon. First thing we have to talk about is that the moon actually travels around the Earth in a counterclockwise direction. I'm going to throw a couple arrows on here to actually show you the motion, and it is moving around the Earth in a counterclockwise direction. We have the Earth in the middle. We have the Sun 93 million miles off to the right. Rays of light coming in pretty much in a parallel direction. We do have an inner circle of moons. We have an outer circle of moons. We have to differentiate which one that is. The inner circle is one that we actually visit or see if we're standing out in space. So if we were on the International Space Station, or better yet, we were on a station maybe million miles away from the Earth, we would actually see the moon traveling around the Earth with the sun side illuminated, the dark side not unilluminated, but we'd actually see it moving around and there would be no phases. So first off, we have to remember that the moon phases is an apparent change in the moon. It's not a real change. So the outer circle is going to be the moon visible from the Earth. Now when we look at the Earth, we're actually seeing one half of the moon, the side that faces. And then we will find out later on that the moon actually has two sides. The side facing the Earth is always the same size. So as the moon goes around the Earth, the side visible by the Earth is the same side. That has to do with, as the moon was forming, the center of mass, the center of core, actually moved a little bit toward the Earth. So we're actually locked in to a Earth-Moon relationship, so that we pretty much see the same side of the moon all the time. Okay, so we've got this moving around. I do want to add one little circle here. I'm going to pick that into a purple. If we move around the Earth, it actually takes the moon 29 and a half days to orbit our planet. So we basically get from this moon right here, which we're going to call moon number 1, to moon number 1 in a counterclockwise direction every 29 and a half days. Sounds like a month. In fact, the name month is actually based on the moon. But you can see with 29 and a half days not going into 365, it posed problems. We came up with 30 days, didn't work. Added 31 days for a few, didn't work. And actually today is February 28th. Tomorrow, 2012, is our leap day, the day we actually use to compensate. And then later on, if we do talk about calendars, we'll find out that if the year is divisible by 200, we do something even different to compensate, because even that 365 and a quarter isn't really 365 and a quarter. Okay, so going around this direction, this is going to be our moon number 2. This is our moon number 3. We're going to call this one 4. Here's moon 5, moon 6, moon 7, and moon 8. Okay, shifting to another color, not so much black, but close to it. Imagine standing right here on this planet, looking up at this moon. What would you see? Well, the visible side lit up by the sun, is facing the sun. That means the dark side is facing away. So what I'm going to do is I'm going to pick a different color than that. That's the same color. I guess I will go black. Okay, so what I'm going to do is I'm going to color in this whole side. This whole side is the non-illuminated side of the moon. I may actually not get it perfect, but close enough. And what do we call this moon when we can't really see it? It's in our daytime sky. It actually has a sun in the background. It rises with the sun, sets with the sun. This is called our new moon. Okay, we move up here. If you think 29.5 days, takes about 2 weeks to get from 1 to 5. Takes about a week to get from 1 to 3. So it's about 3.5 days, a little more, a little less, to actually make it to moon number 2. When this moon moves across, we could literally put another moon there and another moon there, and we could put a moon in between those. We're actually only looking at the 8 moons that actually have the names that we give these moons as they do their apparent change. About 3.5 days, it moves over to moon number 2. I'm going to draw a line right here. This represents the line that shows you the side of the Earth, not a real good line. This line represents the side of the Earth that is visible. I mean the moon that is visible by the Earth. This is the one that is not. If you take a look at it, it's a mostly dark moon, but it does have a little bit of light. So starting at the top, I'm going to curve it this direction. I'm going to color in the left side, the large side. And what does that look like? Well, my daughter Maggie, when she was a little girl, she actually called this the fingernail moon. I think if we were in France, we'd call it the croissant. But here in America, we call this the crescent moon. Okay, moving another 3.5 days, we have a moon that standing right here looking up, left side dark, right side light, looks like a half moon. I'm going to go like this, color in the left side. Now if I was calling this a moon, and I have no trouble at all calling moon number 2 a crescent, if I was going to call this moon, I would actually call it a half moon. But I guess the ancients actually said, well, we've got a half of a half, the half that's facing the Earth, and only half of that's lit. This moon is called the quarter moon. Another 3.5 days, we move over here. Standing down here at this location looking up, this moon is mostly lit. So what I'm going to do is I'm going to curl it off this way, and I'm going to color in the side to make it look like it's mostly lit. And what do we call this moon? This moon is called a gibbous. And this gibbous moon is mostly lit. I'm not exactly sure what gibbous means, but gibbous must mean that we're nearing full, or we're getting mostly filled, because we moved down to moon number 5. The visible side is facing the Earth. I have my kids actually draw a face on here to represent the man on the moon. I just want to make sure that they understand that this moon actually does have an image on it. I don't want them to leave it empty. I let them draw it any way they want to. They can draw beards, mustaches, they can draw whatever they want. But that's the moon I'm going to draw for this one. And this moon is called full. Kind of a mad looking moon. Maybe I should even give him a earring. Okay, we move over here to moon number 6. Another 3.5 days. Looking at this moon, looks like we have a mostly lit moon. Sounds familiar. Except that these moons are going to look opposite this. So what I'm going to do is I'm going to say that the right side is actually dark, the left side is lit up. So I'm going to take this and I'm going to draw this direction, coloring in the small side. This moon again is mostly lit up, and this is called the gibbous. And now we have a problem. We have 2 moons called the same thing. They do not look exactly the same. So now I'm going to get a different color. I'm going to pick a different size pen. And what I'm going to do is I'm going to draw an arrow moving in this direction from new to full moon. And then I'm going to pick another color. And I'm going to say from full moon to new moon. And what we have is we have 2 basic halves to this cycle. Moons over here are called waning. Waning, of course, means to have material taken away, or ending, or vanishing. This moon is actually getting smaller and smaller as we move back to new. This side over here, this side we're actually adding to it, this is called the waxing side. So this is a waxing crescent. This is a waxing quarter. This is the waxing gibbous. Full moon and new moon are not getting smaller or larger. They're just called full and new. The rest of these moons actually do have prefixes. You can actually call that quarter moon up there if you want. You can call this thing a first quarter, but you can also call it a waxing quarter. So, back to moon number 7, we're again half and half. And I know it looks like to you that the left side is dark, but standing on the Earth it would be the right side. So what I'm going to do is I'm going to color in this side. Looks like I have a smaller pen than I had before. I'm going to go ahead and keep it at number 2, which is what I have. Okay, and this is another quarter moon. And this one would be called, if this is the first, this can be called the last quarter. If this is the first, this could also be called the third quarter. It can also be called the waning quarter. Okay, and this last moon, number 8, if you take a look at it, it is a mostly dark moon. It has one side just a little bit, which tends to be the left side, again, looking from the Earth. So what I'm going to do is I'm going to actually draw this thing this direction. I'm going to shade it in a little differently than I drew it because I didn't draw it quite the right way. You know what? I'm going to do it the other way because I just said it was a mostly dark moon. I don't know why I wanted to save the writing, especially with this number 2. And excuse me, I seem to have something caught in my throat, and I'm probably going to be clearing it periodically. This is another crescent, or another crescent moon, except this would be the waning crescent. Okay, so we have the light coming in from space. The moon does not go through phases. It actually looks like it's a quarter moon or a half moon all the way around. Sitting in the Earth, sometimes we have the dark side, sometimes we have the light side. We have the growing getting bigger side. We have the shrinking getting smaller side. If you know anything about mythology, there was a goddess named Luna, and she wanted a monument built to herself. And what she did is she had her slaves build her a monument. They started from scratch. They built it up in space. People here on Earth saw it get larger and larger and larger. It got full. Luna looked up, especially if it was built like that face. Luna looked up there, wasn't happy, and she demanded her slaves to rip it down and start all over. So it got smaller and smaller and smaller and smaller until they started over. It kept going this direction. And if you've ever heard the word lunatic, that comes from this seemingly crazy goddess and trying to make this monument to herself. Okay, if I go down a little lower, let's see if we can actually make any sense out of these. I have a couple of moons here. We'll actually call this one moon, and I got to make this pen a little bigger. We'll call this one moon number 1. Can you tell me what moon number 1 is? Looks like the right side's bright. Oh, and there's one more thing I need to add up here. One way you can remember waxing and waning, if you do look at waxing moons, the right side of this moon is bright. So if you actually remember that the right side is bright, maybe you can actually, because these two rhyme, you can remember right side bright is the waxing, and if it's not the right side bright, then it's the other one, waning. Okay, so let's go back down, look at that moon, moon number 1. If you do take a look at it, it looks like the right side of this is bright, so this is a waxing moon. If you take a look at it, it's not full, but it's pretty close. This is the waxing gibbous. Looking at this moon, the right side is not bright, so this is a waning moon. This is the one that's half and half, very much like this one right here. This is the waning quarter, moon number 2. Moon number 3, totally dark, that's your new moon. Moon number 4, again, looks like it's totally lit, but it's not the right-hand side, it's the left-hand side. It's that moon right there. This is the waning gibbous. This is moon number 5, left side crescent, waning crescent. Moon number 6, this is the full moon. Moon number 7, this is another crescent, right side bright, that's the waxing crescent. This is moon number 8, right side bright, this is the waxing quarter. Another thing I have right here, this is what's called earth shine. Sometimes when you actually get a very small moon, which means not very much light, usually it's the crescent moon, and you get a sky condition and the atmosphere conducive to this, we actually do get the light coming down, striking the earth, coming up and actually hitting the moon, and then coming back down and striking the earth again. And we actually call this earth shine. And sometimes you can see the entire moon, even though you can only see a very small part of it lit up. And this is all because of something called earth shine. It's the luminescence, or the reflection of the sun's light from the earth back to the moon and reflecting back. The moon is much more reflective than the earth because of all of its light color. White reflects much better than darker color. Okay, the last thing I want to do is I want to talk about eclipse. This top picture right here, this actually sort of explains why we don't get an eclipse every time we get a new moon and a full moon. And we do have to actually have the moon because we need a sun, moon, earth, or a sun, earth, moon setup. We need a new moon to actually block out the sun. And we need a full moon to be blocked out by the earth. But we don't get a lunar eclipse or a solar eclipse every 14 days, or not even once every 29 days. It's actually a relatively rare occurrence. Solar eclipse, I think, happens every year and a half. Lunar eclipse about that. The reason we don't have it is because that the moon's orbit is tilted about 5 degrees from the ellipse, the sun-earth line of orbit. So the only time this can happen, if we get a new moon there, the shadow passes above. If we get a full moon down there, the Earth's shadow passes above. If we're down here, the moon's shadow passes below, or the Earth's shadow passes below. The only time this will happen is when this orbit intersects our orbit, and the new or the full moon happens right there. So it actually has to be this point right here, or it has to be, because remember the Earth, sun, earth, moon, it actually hits right there and right there. We wouldn't get an eclipse if this is the moon's orbit. If we do get a new moon right there or a full moon right there, we can get it. But the chance of that 29.5 days happening at that location right there, or that location, or this location, or that location, especially these two, it doesn't happen very often. Now, it does happen in other places too, but that's really the only place that the node would happen. Okay, so pick a different color. Try a pink. This is called a ray diagram. And what ray diagrams do is they actually follow the rays of the sun, or photographers' rays of light. Lots of people, anybody who uses light can do a ray diagram. It's actually seeing where the light rays are going to affect your picture. In this case, we're talking about a celestial object blocking out the light of a illuminated celestial object. And what you do basically is you take the top part of the sun, you take the top part of the blocking object, and you draw a line from the top of the sun to the top of that blocking object, from the top of the sun to the bottom, from the bottom of the sun to the top, and from the bottom of the sun to the bottom. And what it does, no shadows on this side, it actually shows you how you get a darker part of the shadow, where if you're in this part of this little triangle, there's no way you get to see any of this sun. And the lighter part of the shadow, where if you're in here, you can see if I drew a line straight across, I can see some of the sun. If I'm up here, I can see basically all of the sun. If I'm right there, I can see all of it. If I'm down here, the closer you get to the outside, the more of the sun you get to see until it's all sun. Or the closer you are to the center, the less the sun you get to see until you get none of the sun. This inside part, this is called the umbra. Umbra meaning, like umbrella, you're blocking out. 100% total blockage in the umbra. This outer part is called the pen, all one word. Penumbra. Penumbra, you tend to get more light. If you are in the umbra, we can get what's called a total eclipse. So I do want to write that over here. Umbras can give you total eclipse. So you can get a total lunar eclipse, total solar eclipse, if you can get that blocking body inside the umbra of the blocked body inside the umbra of the blocking body. If you do get the penumbra, then you get what's called the partial eclipse. Partial meaning it only partially blocks out. Okay, so this is the regular ray diagram. These are the two diagrams for the actual eclipse. And if you take a look at it, what we have here is we've got the Earth. We've moved the moon on the far side, so the visible side is facing it. This has to happen during the full moon. And when that actually does happen, we get the moon to disappear. It actually is blocked out by the Earth's shadow. It only has the umbra in this diagram. We really would want to draw another line sort of like this, another line sort of like that. For the penumbra, if it's in the umbra, we have a total solar eclipse. If I pick another color and I put a moon right here, that would be a partial solar eclipse where some of the sun, but not all of it, is blocked out. If we move down, and actually this one is called the solar eclipse. This one is the lunar eclipse. Lunar eclipse has to happen at the opposite of that full moon. It has to happen at a new moon. Like that purple. And again, we have to draw the other two lines to show the penumbra. Don't know why they actually gave it to you here and they don't give it to you on these. If you live inside this little triangle on the Earth, then you're going to experience what's called a total solar eclipse. And I may have actually said solar. Let me restate that. This is the lunar eclipse because the moon does disappear. And this one down here is the solar eclipse because we are making the sun disappear. So this is the solar. And I got to get a pen. So if you live in there, you're going to, in that very small area of the blockage of the sun, you're going to experience a total solar eclipse. If you're located anywhere in these other two places, you're going to get a partial. Okay, so lunar eclipse, moon moves into, it's a full moon, moves into the Earth's shadow, the moon disappears. Solar eclipse, the Earth moves into the moon shadow, and the sun disappears. It's a lot easier to see why more people see lunar eclipse than solar eclipse. Look at the size of the shadow. Look at the body that's doing the blocking. You take a smaller moon and you move it into a larger shadow, it's got to happen more often. If you have, and visible by more of anybody who's basically on this side of this Earth sees this eclipse. So in reality, more than 50% of the planet sees a lunar eclipse. Where this one, a very small, and I'll show you a space view of a solar eclipse moving across the surface. Wish I could show you the moving apart part, but this program doesn't show me. Let me show you animations. But again, if you're in the umbra, you're a total eclipse. If you're in the penumbra, you're a partial eclipse, and you can have that as a lunar or a solar. Okay, if we scroll down, this is actually two pictures. This picture is actually showing you a solar eclipse. The moon being 400 times smaller, but also 400 times closer, makes a perfect blockage for that sun, 400 times taller, larger, and 400 times farther away. They have the same apparent size in our sky. No other planet that we've discovered has a satellite that can do this perfectly. Now, we are going to have issues because the moon is moving farther away every single year, and eventually it will become too small to block it, but that won't happen in any of our lifetimes. Okay, what you're seeing here also when we talk about the sun later on, this is the corona of the sun, the crown layer, and only visible. It's a very bright area, but not near as bright as the body of the sun. It's only visible if we can actually cut out that very bright part of the sun. So this is the total solar eclipse, showing you a beautiful corona. This is a total lunar eclipse. You may say, okay, should be black, it's in there, but the way it really works, if I was to draw a larger Earth here, should even be larger than that, it's about 6 times larger, and then draw this atmosphere, what does happen when sunlight comes through? Sunlight we normally imagine coming through as being sort of white, but what it does, it refracts and diffracts in our atmosphere, turning blue. And then when the blue is gone, it turns more to orange. And when the orange is gone, it turns more to red. And what happens is this acts like a lens, and it bends light to strike the moon. Same thing down here. We get the blue turning into orange, into red. We get the reds coming down, and that can actually be sort of blood red. Hits the moon. It's only illuminated by red light. That light comes back, strikes the Earth to an observer. Had to actually cause a lot of scare. But this is a total lunar eclipse. And if I get rid of those lines, get rid of that atmosphere and that Earth, that is a total lunar eclipse. Going down to this one, this is the International Space Station viewing solar eclipse. Very inside, the umbra part of the shadow. If you did live in, let's say it moves down here towards like 4 o'clock on the screen. If you lived in this little section right here, you are experiencing a total solar eclipse. So very small parts of the population can live there. Now if you take a look, you can see this thing gets fuzzier and fuzzier. This is the penumbra, toward the inside much darker than towards the outside. And let's say it actually reaches all the way out to this location. So what happens here, these folk all get to see a partial solar eclipse. What does that mean for the person out here? No eclipse. Person down here, no eclipse. Sometimes the shadow doesn't even hit like here. This could be no eclipse. But this thing could have actually moved all the way across. I don't know. All I know is that it's right here. Say it moves in this direction, very small percentage. Maybe 15% of the planet gets to see a solar eclipse, and 1 to 2% get to see a total solar eclipse. It's very unfortunate. Okay, if you go down to this picture, this is an actual picture of the full moon moving around the Earth and finally moving into the penumbra part, the lighter part, and then into the umbra part. And this would actually be a partial eclipse. It looks like it didn't really get into the full umbra. I don't think I'm going to talk about it in here, but we do have what's called an umbral eclipse and a penumbral eclipse, and even when we actually move between the umbra and the penumbra, half and half, that's called, I think, a U2 eclipse. And then it keeps moving out into lighter areas. It can even be into the penumbra and the regular visible part. That would still be a partial eclipse, although it would be very hard to see. But if you take a look, you can see the shape of the Earth's shadow. It has a roundish shape. And if we actually had the picture all the way around, it would look very roundish. But that is a lunar eclipse where it moves, the full moon moves into, and then again out of, or over a period of hours, maybe 2 hours, 3 hours, 5 hours, moves out of that shadow, and it actually goes from a regular moon to a regular moon, being strange in the middle. In the last two pictures here, what I have is I've got the Sun, and we have the second planet from the Sun, Venus, trying to give us a really total eclipse. Now Venus is a much larger body than the Moon, but it's a lot farther away, and it can only really cover less than 1%. So it's moving across the face of the Sun. This is what's called a planetary transit, trying to be an eclipse, but it can't. I'm also getting a jet airplane and its condensation trail trying to eclipse the Sun. None of those are actually able to do so. Picture 2 is actually showing you Venus again. This is the International Space Station as it moves across the face of the Sun. Again, both of those trying to cause an eclipse. Neither one able to do so. Okay, well, I hope you enjoyed it, where we actually did get a chance to talk about how an eclipse is set up, looking at what an eclipse is, why we don't have an eclipse all the time, and then as well as talking about the apparent change in the shape and maybe even the size of the moon. We didn't even talk about perigee and apogee when the moon and the Earth get closer or farther away. We can have a largest full moon. We can also have the smallest full moon, and then we have lots of normal full moons. Same thing with any of these phases. But we did talk about right side being waxing, left side being waning, so we can tell the difference between a waning crescent and a waxing crescent. And then we tried to show you the geometry of how and why we do have moon phases. Okay, well, I hope you enjoyed the show. I appreciate it, and hope you get a chance to listen to me more. Bye-bye.